experiment, but he has been associated with CMS since 1993. And his main interest, of course, is in standard model physics. And last few years, he has also been very active in the INO experiment. So he's going to tell us about the WLCG. Please go ahead.
Just give me a minute. I hope you can see my slides and you can listen.
Yes, yes, we see them.
Okay. I am first of all sorry, Sunanda, that somehow I have to go early. So most likely I will be in your talk, but I do not want to take any chance. Okay. So I will try to give an overview of this Indian contribution in WLCG. So this is that Indian contribution. So this is this. I took a very old map where this Indian where the various tier 2 and tier 3 centers are there, and some of the this plot it may not be right. Something it came in between, it disappeared. Something is coming. So, but the main thing is that this is this two tier 2 centers. One at the TIFR for CMS tier 2. Another one is the ALICE at WLCC. So I will mainly give you the talk about this overall scenario of this development of the tier 2 center at CMS at TIFR, but nearly the similar scenario of ALICE tier 2 at WLCC and other tier 3 centers related to the ALICE. I will not talk anything about that, but you can just more or less scale up what is the tier 2 at TIFR. That way developed this is the ALICE tier 2 also at WLCC. So it started long back. Sorry, it started long back. It started in 2004 or 5. That time, actually, again here this project started, and that time this was this main point was what was the plan? How it I cannot. Why the top part it went there? I want to see this. No. It's covered in the top part here. Just a minute.
No, on the screen we can see very clearly, no problem.
Yeah, so the heading is seen like this.
Okay.
Govindada, we can see clearly, no problem.
Okay, sorry. So during the planning phase of this initial phase of these tier 2 centers in India, and that time what was anticipated? Again, this number may not be exactly right. In the CMS detectors, there were 40 megahertz collisions, and in the level 1 and level 2, we have a suppression of this data. But eventually, we are having roughly this initial phase, it was 225 megabytes of data supposed to store. And that time the rate was considered about this 100 kilohertz, and now the rate is about 1 kilohertz. So this number was initially it was about 100 kilohertz. That was the plan. And so this is this huge amount of data. We have to how we can use this huge amount of data worldwide. And this is not only for the CMS, similar case for this all other experiment also. So for that point of view, that time this worldwide LSC computing grid concept came. So this the main thing is that when the data will supposed to collected, it will store mainly at the sun and the tier 0 centers. And there will be some reconstruction, but it is not the mainly the data will store, and permanently data will be stored in the tier 1 centers. There was a few tier 1 of the order of 10 tier 1 centers. But the main workforce for the simulation and data analysis, it will be distributed to these various other centers, is called the tier 2 centers. And TIFR is one of the tier 2 center and WLCC is another tier 2 centers. And these tier 2 centers are also associated with this fourth tier I did not mention. This is called a tier 3 centers. Basically, there is mainly these are the dev stock to many institute facilities where they link with the tier 2 centers. Basically, these users, when they submit their job where the job will station, this output will come, or user can directly use this tier 2 storage space. So that's the tier 3 centers we have in India. Almost all the institute has a tier 3 centers. And these tier 2 centers help to this all the tier 3 centers and the related students. Okay. So this is an international collaboration to distribution, analyze the LST data. And as I say that this main goal is that integrate computer centers worldwide that provide computing and storage resources in the single infrastructure accessible by all LST fields. So that was the goal. And now let's see, I just go back a little bit history. Actually, I try to go back even before that. I know that it was even before 2005, but I could not trace my old files. So here is the sum of this history what we have written somewhere in 2007. So it was written that 2005 and 6, we had only the link with the 45 Mbps link with the GANT and ARNet, and this is the European and the Indian community that the agreement was done, and MOU between the DST, DAE, and this CERN, it was made in 2005 or 6. And then the Gorula, this National Grid Initiative, is started by the CDEC, Center for Development Advanced Computing, and that is this it's come in between to develop this infrastructure mainly for that for this internet connectivity. Then also in the short period, I think in 2006 to 2010, we had an EU-India grid projects, and that's also some dedicated fund we get from these European organizations to have some internal link. And then end of 2007, there's a dedicated SAN link is coming, direct DA to the TIFR SAN link. It started from this 300 megabit to roughly 1 gigabit. That's gradually it comes in around 2007. And it is little more than as I say that a grid. This is this connecting this all the computers all over the world. So this is one of these linkages at the main backbone of this grid computing systems. So this we say that in 2009 we have this 1 gigabit dedicated P2P link TIFR to SAN, and in upgraded to this 2 GB in 2012 and 4 GB in 2014, and gradually it is upgraded. And at present we have 8 gigabyte, 8 plus 8 gigabyte links. I'll just later on I'll just show one of these all these chronologically how it upgraded in year wise. So this 8 plus 8 means 8 dedicated link. If the one link is failed, then we have this another link. And for this RAM 3, gradually we are planning to have this 40 gigabit link to the NK Mumbai to Geneva. So this is this link in this connectivity around 2019. So this was this connectivity that actually is 10 gigabit links. It was one go to the NK and one go to dedicated link to the SAN. And this one went to this Amsterdam, another link went to this Singapore. And then it was little bit of change in 2020. This all the links now become this NK links. And but this is now instead of 10, it is 8 gigabyte to 8 gigabyte link. And basically the linkage is like this. We have the TIFR, we link to this NK, and NK has the two dedicated links. Either one of them we will use for our connections, and it connected to this the GAN, and then it's the SAN in the different links. But the main point is from here to here, we can go either one of these link is one of them link has some problem, then we go to the other one. And then at present in TIFR, we have this 14 server racks and network racks. And this infrastructure has this 150 kilovolt ampere UPS, and which can store this 20-minute minimum power to run the systems. And the dedicated power systems, and the cooling is 14 RT, and the networking, as I say, that 8 gigabit to 8 gigabit link, and the state of the art switch routers and firewalls we have. So these are different simple pictures of these our systems. And also in the software side, we have the CBMS and the grid middleware and all components we have. For the storage, we have the DPM, till we have the DPM and CentOS 7 on the head node, the 53 disk node, and head node disk nodes are this is the different features are there, and we use these are the protocols. And at present, storage is roughly 11 petabyte of data. And in the computing, we have this HT Condor and HT Condor C. So this is this two. I will come to this one point. This is we have the two systems for this computing at this moment, though we are not using dedicatedly this one. And the total cores up to 14,000 in the productions. And also we have started initiative to use the GPU in our system. We know that in future GPU will take over the many of the CPU. So already started. We have these GPU machines in our tier. And of course, the DNS, accounting, transfer monitoring surface, and commissioning, and everything to the puppet. So now, as I said that, and tier 2, we are also associated with this tier 3 centers, which is mainly dedicated for these mainly Indian physicists, Indian students, and not only restricted to the Indian students, we also allow some of the foreign students who are the collaborators with us or who are earlier with us. But the case by case basis, we also give that facility. So mainly thing is that we have the dedicated tier 3 Condor clusters where we have these 350 job slot now, and the multiple logging machines are there for this, and dedicated storage for these users, roughly 300 terabyte dedicated storage and growing. And this is growing, and this is separate than the tier 2 storage space what we allocated for these users. And at present, there is a record wise, it is more than 100 students all over the India as an account, and on the average, more than 50 students on the average is using this facility on the regular basis. Okay, so these are our tier 3 facilities we have. And okay, so this is this evaluations of the upgrade of the grid computing center and TIFR. So let's say, as I said, in around 2009, we have roughly 150 cores, and equivalent to this CPU HEP specification. This is this number. And these 150 cores to now it comes down to roughly 14,000. Similarly, the storage initially in 2009 we started even much smaller, and this was 450 terabytes. Now we are having roughly 11 petabytes. And this is the power. What is the power? Is power we use, and gradually 35 kilovolt ampere transformer to now we have a 120 kilovolt ampere transformer. And this is the linkage roughly 1 gigabit per second to gradually increases. Now it is the 8 plus 8. And here is this number we put in the percentage. This percentage is that what is this HEP specific? This is this computing power or the storage we places to the CMS system, CMS grid computing system, and compare that what is the relative fraction in terms of the CMS total resources. So initially it was 2 to 3%, and the storage initially we had a little more and then go down. But recently, I will come to later on once more. This our storage capacity on the computing space capacity also increases drastically and very large the last 2-3 years. And this is the plots, some performance distributions, and just ignore this bump. Otherwise, this will be cumulative increase of the distributions. So this what is the number of jobs run in these tier 2 centers. And this is this roughly 500 million event was processed here. And here it shows some range. Actually, we do not go back to this at present in this server that we cannot go below 2017. So 2017 to 2021, what is the availability and the site reliability? And we know that except the shutdown, otherwise this is the availability and reliability of this tier 2 centers is above 90%. And then this is this number. You may know this number of cores is used in this all over the this in the grid computer system for the 4 different experiments. This is for the Atlas, and this is for this I think LHCb, and one is Alice, and again the CMS. This is the different colors. So the number of cores used in the different years, these years to recent times. And then this is the computer delivered in the specific in this. This is the unit in this teraseconds. That's the way unit we can read. This is here specific is in hours in 10 to the power 9. That unit you have to read. And this data is this data transfer in this grid. How much is this? And this is this number in tier 2. So what is this disk places in 2022? For these different computing, different systems, again, the CMS and this, all these 4 systems. Main experiment. So just here I try to tell you a little more about the end part. The 2017 and 18. If you look for the TIFR resources, and we just mentioned this is the number, it suddenly increases. And here is this plot number I just showed this CMS computing systems. What is the total computing say here specific? Okay, just see this bar, ignore these numbers. And similarly, the storage systems for all over the world, it was mentioned the country wise, what are this computing facility the defined country has, and here is the storage in the defined country. And if I see these numbers in India and Italy, these numbers are nearly same, and compared to the USA, these Indian numbers is half. But keep in mind, in India, this tier 2 center is the only tier 2 centers in TIFR tier 2, and Italy and USA there is a many more tier 2 centers, not a single tier 2 center. So this is the federation. So this is not a single tier 2 center. So in that sense, in the last 2 years, we are servicing the CMS tremendously in the through the computing. And then, okay, I will not go in detail because of the shortage of time. But as you know, this computing is enormously increasing. The computing requirement is enormously increasing, and we anticipated it earlier. And also not the we. This is all over the world. So this we are trying to use this grid. This is the cloud computing systems, and Formula they did I think with the Google, but TIFR mainly actually I have to specifically say that this is the main thing backbone is the Breeze. He collaborated with this Microsoft and to establish this cloud computing system in the cloud computing system which can work for this CMS grid computing systems. And it was established. Actually, this is the, let's say, this is, okay, without going in detail, this is this cloud computing system, this is the CMS environment, and all this infrastructure was developed in here, and then this submitting the job, and through this TIFR, all kinds of protocols, basically this is the CMS, the outside people should not see the CMS storage, all these protocols was taken care of it, and it was developed, and it was established that we can successfully use these cloud computing systems when it is required, that can be faced through these our tier 2 centers. So then that was the present status, and now as I think this figure already Suchinda has shown that LHC will go up, and that our more data will collected and the more computing powers is required. And also, this when the more computing parts is required, we know that we may not able to store or pass this all this data to the network. What in the present scenario we had. So in the data also there was a many different scenario, many different reduction we did. Mainly this raw data, simulated data, but at the user point of view, when the LSC started, that time we used to say that analysis object data, that is the event size is roughly 400 kilobytes. But in 2014 onwards, that time people used to reduce this data size to 50 kilobytes. And now we are trying to use even this user object, some of the user object data files, the nano AOD, which is just a kilobyte of data size. That is how we try to reduce it. And to reduce it, we have to run some computing processes, So this is just say that what is the required time is required for this. And particularly here, if you see this computing is this CPU is the second is required in time. So in time is 2017 to let's say 2017 and onwards. It is gradually now 2021, 22. With the phase 2, this number will gradually, not the gradually, this is drastically increase. And this is also similarly for the storage. This will drastically increase. And then, so on that plan, we had a plan. So we are already starting this, our data center, what we are having, already we are extending these data centers to have these new computing systems and also upgrading this existing bandwidth that's already I mentioned. So this is our tentative plan that at present we have, this is the scenario at present we are having. This is the storage, power, connectivity, and we we just ask this funding agency for this support in the near time, that planning this rate 2024-25, we will have this 20 petabytes, and this power will increase roughly 3 times, and connectivity will increase. And similarly, we are planning, or not yet requested anything, but this is our plan that we will go in 2027-28 to cope up with this high requirement by the CMs. And also in parallel, more job slots for the tier 3 and the local space to support the Indian users. And so in summary, I said that TIFR, basically T2 in TIFR, has played a leading role in the Indian part of the CMS experiment at LSC. So already you had the hardware and computing also, we did a lot. And the national contribution to the CMS international collaboration at LSC, and our average availability reliability is about 95%, other than the scheduled shutdown period. And one of the largest tier 2 centers, and active since, officially it is active in 2008, means 2008 onwards, we have some of the CMS data in our simulated data in our centers, and operational 24/7. And to run this, there's hundreds of different test and probe monitor this health system that's continuously going on, around the clock monitoring the support. And the support, actually, this is two kinds of supports. One is this to update, this is the CMS, this grid, its connectivity to this all over the world, this connectivity. And another support is mainly for this all the Indian students who use these our tier 3 centers, our tier 2 centers and tier 3 centers, and their requirement, their question, their problem, these also try to solve. So as in short, we say that we are also the tier 3 centers what we are having. This is again I'm saying that this is dedicated mainly for these Indian students. And we are ready with these HIP cloud computers, and these already commissioned 2017, but different policy reasons we could not use this, but we are ready with this cloud computing system. As soon as the CMS will open this door, we'll ready to access this cloud computing system. Yeah, I think that's all from my side. Thanks.
Very much. Yes, so I think there's already a question from the room. So Kajri.
Yeah, of course, we know about this grid. So I want to make a comment. about this computing resources in 22. We were hit by the cooling problem. This is an infrastructure issue within the institute. So at present, the number actually is reduced to 1/3. So we are running at the level of only 30,000 HS06 CPU. Storage is fine, but we are trying to correct the situation, but it's a long-term effort. My second comment is about the cloud computing. Of course, Bridge is in the room. We can comment more. But main thing is that sometimes people ask this question, what about the data security? So this is on the fly. In an elastic way, we extend the T2 facility. So data stays on in TIFR rather in local disk. And the computing only is done in the Azure cloud. So that's how it is done. And then it comes back, it gets stored in TIFR disk itself. These are the two comments.
Okay, thank you. Praveen?
Yeah, thank you very much. Thank you, Govinda, for your wonderful and excellent talk. I have two very small, simple questions. Are we at TFR working on any developments of the Condor technologies, or just we implementing the Wisconsin versions? And secondly, like from
Just a minute. What is the question? Wisconsin is not come into the picture in tier 3, the grid computing system at all.
because you
Wisconsin is
mentioned
not,
about this.
Wisconsin is not part of, Wisconsin is not directly linked to anything with these TIFR tier 2 centers.
No, I'm saying about the Condor technologies. Condor technologies.
No, this is complete. Condor technology. This is the Condor technology.
Yes.
This is the standard technology. This we did not develop, we used it.
We use it. Okay. Secondly, since when this tier 3 facilities come into the existence, like
Since when?
tier 3 came into the existence.
Tier 3
at TFR.
At TIFR, as soon as the tier 2 centers in TIFR, we had already since that time we had the tier 3 centers. Tier 3 actually this is okay. In physically wise, this is not the different room. We have the dedicated space or the computing resources of this storage. It was separated out from this global tier 2 and those space and computers used for this local user. So this is we started as soon as this our tier 2 came, that time itself tier 3 also. Okay.
Okay. That's what.
So for the grid computing, some of the facilities were developed along with the Condor team of Wisconsin. That was Bridge who was doing things. GAHC. Maybe Bridge can.
Yeah, so I mean, I can just comment on this. We had contributed some of the codes in developing gap with the Condor, which basically interacts our grid to the cloud system for Azure. Sorry.
Okay, I think there are multiple speakers and mics in the same room, so we're getting a feedback.
Okay.
Bridge, could you try again? I think they muted their.
Sorry. So, yeah, I just wanted to comment that, yeah, that's true. We have been using the S2 Condor developed by the Wisconsin originally, and at times we have also tried to working with the development teams in contributing some of the code features. For example, developing a gap which connects the Azure with the Azure cloud with the provides an interface for connecting to the Azure APIs from our grid protocols. And on the other point, I wanted to discuss, yeah, I mean, and for the clouds, the point is our CMS software is completely open source now. So there is absolutely nothing which is where you, particularly for the part of simulations, the data as well as the simulation, as well as the code itself, it's all open source. So there's nothing for us to be able to worry about saving or hiding, except for the obviously the data which gets generated in the detector. That separate part, and that is kept mainly in the storage within the WLCG storage systems.
Okay, thank you. Sunanda, do you have a comment?
Yeah, it's a very minor comment. Okay, so the thing is, okay, I mean, the entire WLCG activity really started with a WLCG meeting, okay, which was held in TIFR in way back in 2006. And I think, okay, because of that, okay, I mean, some of the people, okay, from CERN as well as from US, okay, I mean, they got in touch with the DE chairman and also initiated, okay, the high bandwidth connectivity. So that was possible mainly because of that. So that was a comment. Okay, I mean, I have a short question. Okay, what is the definition of an Indian user? What is the definition of a user?
Okay, Indian user, I say that this is the Indian student, Indian CMS student. Those are the main thing. And let for example, who was this Indian student now not in India? Some of them, or sometimes let for example, who are the collaborator from the outside also, we are giving them. So the Indian user means the Indian student from the Indian Institute. That's why I was just trying to mention.
And also ex-students, that's all.
That's done. That is the separate second and third part. Is the H2.
Isn't it not like something whatever the institute is issuing the grid certificate to connect to the CERN servers? Like, no, I think that
No. It is not that. The tier 3 is only for this. This is dedicated. Okay. Tier 2 and tier 3. Tier 3 is this only. We can. There is some space. Only we can decide who will use. This is not this all over the world. Okay.
Yeah, so I think Rajiv has another question.
No, this is just a short comment to Govinda. Can you go 2 slides back? Yeah, this one. No, that one only. You are projecting power requirement increase, which is presumably not sustainable at your Mumbai site. I'm not completely sure whether things have changed. In the context of our computers, at that time, we were actually told that such power is not available. That is why our major computing center is in the balloon facility at Hyderabad. And the similar side comment is that there we got a 1 megawatt line installed. So there the power may be possible if you actually manage to get space and start doing things.
So this discussion is going on that is TIFR are trying to do this centralized computing system where it can be facilitated everything. Sometimes the discussion says that we may go to the Hyderabad, this is our TIFR new centers. But we are going to have a new transformer, and that's also a discussion that if we have the new transformer, then we may have this power.
This table was made 2 years back.
Yeah.
Actually.
No, so that I'm saying that this is if this power, this new transformer comes, then we may have the power here also. So this is all the possibilities are there.
Slide everything by 2 years.
Okay, thank you. And thank you to the speaker again for the talk. So we go to the last talk.